Hi everyone, welcome back. In this lesson, we're going to start talking about the concept of loops in programming. And we're going to build on the example we just did in the previous video. So if you haven't watched that yet, please go back and do this. And yeah, we're going to explore the syntax for creating loops in P5. And also we're going to talk about why loops are really useful and just really start. This is where things start to get interesting, in my opinion. Okay, so let's dive into it. So this is where we're going to start off from. In the previous video, we had this sketch, which just to do a quick little recap here, right? We had this sketch, which it looked at events to have code that runs at a specific time. And we used the mouse pressed event at the end here so that every time I click inside my sketch window, can't hear it probably, but I'm clicking my mouse every time. And some random variables are being initialized over here. Some of them are fixed, some of them are getting random values. And we're using all of these variables to set stroke and fill color and then draw a circle at a random location with a random diameter. And also I can press the B key if I want to start over and erase the background. All right. So let's say, for argument's sake, let's say we wanted to, right now it's only creating one circle every time I click, okay, because it's only drawing one circle over here. Let's say I wanted to create, maybe 5 of these circles randomly every time I click so that the screens fills up a little quicker, perhaps. Okay? So if we didn't have the concept of loops, this is how we would be forced to approach this. And by the way, never ever write a program in that fashion. But just to demonstrate the idea here, I'm going to do a little bit of copy and paste. So please don't copy that. So let's say we wanted to draw 2 circles. Okay, every time we click the mouse. Well, we could take this block of code that we have here, just to make it a little easier to see. I'm going to connect these with the white space. Now I cannot redeclare variables inside a particular context here. So I have already defined diameter and H and S and B. So I cannot define those twice. So what I'm going to do is just remove the let and just reassign their value to something else. Okay. So here we define the variable, and here we just replace their values with some new random numbers. And I guess technically I wouldn't need to do that, but we'll leave it. So now what happens is every time I click, right, I'm drawing 2 circles. Okay. What if I wanted 3? Bear with me. Okay. Again, never ever do that. You're about to learn the basic building block that will allow you to avoid doing something as foolish as copy and pasting this section of code, but this is just for science. Okay, so now every time I click, right, 3 new circles appear. Okay. Let's say I wanted 5. No problem, right? Copy and paste. Every time I press the mouse, I get 5 circles that show up, right? Okay, so that's fine. Now, how about I wanted to have 100 of them appear at once? Okay. Now, this will start to get a little bit annoying and a little bit hard to manage, right? I would have to copy and paste this 100 times. And what if down the road I decide, actually, these would be better off as rectangles, right? Then I would have to go and change so many places in the code. That's not even funny. Okay, so we never want to be in a situation where we have to do this kind of copy and pasting when we're programming. Instead, what we want to be able to do is leverage some syntax that will say, okay, here I have a section of code that I would like to repeat. Okay, I would like to take that block of code and just let the program do the repeating for me. This is fundamentally, this is really what programs are good at, right? They're good at just carrying out instructions any number of times, and they don't get tired. They go very, very fast. This is where programming gets very interesting, because now all of a sudden we'll be able to say, here, take this little recipe, this little section of code, and then repeat it 10 times, 100 times, 1,000 times, right? 10,000 times. So being able to create repetition in our code is going to enable us to take our ideas and really scale them up significantly. So let's explore the syntax that we have in JavaScript to do that. There's fundamentally 2 ways that we can create loops. One is called the while loop, and the other one is called the for loop. One is a specialized version of the other. So we're going to start off with the while loop, and then we'll explore the for loop afterwards. So first off, let's take a look at the syntax. Okay. So the while loop works something like this. It says while, so this is a new keyword we're going to introduce. A particular condition is true, right? Then we're going to open and close some curly brackets, and we're going to repeat a section of code. Okay? You may notice that this is very, very similar to the if statement from last week. Okay? The only difference is that it will repeat the section of code instead of running it once if the condition is true. But everything that applied to if statements, right, which was how do we format the condition, applies in the context of a loop. So that means our condition when we loop in programming is going to have to be number based, and it's going to have to be a true or false kind of scenario. Right? So let's do an example. Now, in most cases, when you set up loops, right, you're going to have a fixed number of repetitions in mind. There are instances where you might have an algorithm that isn't sure how many times it's going to need to repeat. And so those get a little bit more specific. We might have examples of that later on in the term. But for now, we're going to set up a basic loop where we know ahead of time how many times we would like to repeat. Okay? So we're going to say while, and just for now, I'm putting in just the skeleton here. We'll say while a condition is true, I'm going to enclose this section here, right, inside some curly brackets. And I'm going to indent, right? So I'm going to select here and hit tab. Or if I'm lazy, you could also do the tidy code button, okay? So we're going to say while a condition is true, we want to be able to repeat this block of code. Okay, so this is the block of code that's randomizing the numbers, drawing the circles. I want to repeat this for a certain number of times. So we said, okay, conditions have to be number based, which means I need to be able to ask, compare two quantities and ask if the answer is true or false to determine if we should keep repeating in the while loop or not. So in order to do this, we're going to create a variable. We're going to use that variable as a counter. So because of that, I'm going to call it counter. We're going to start counting from 0. This may seem a little counterintuitive, no pun intended, but we'll get into that habit. Why we count up from 0 when we program is going to make more sense next week when we talk about this other syntax called arrays. But just bear with me. We're going to start our counter at 0. And then we're going to say, okay, in the while condition, we're going to take a look at that counter. And we'll say, as long as that counter is, let's say, less than 10, okay, we're going to repeat the content of the while block. Okay? So this isn't going to mean that whatever we put inside the while loop is going to keep repeating. It's going to run the code, go back to the top, repeat, and every time it's going to check, is this condition still true? Which means we're kind of missing one component here, which is we created a counter, a variable that we're going to use to count with how many times we repeated. We set a condition for the number of repetitions we want to get out of our loop. And then the last ingredient that we're missing is that inside the loop somewhere, we need to increase, right, our counter. So in other words, every time we go through the content of the loop, when we're done, before we go back around again, we're going to take the counter and we're going to add 1 to it. Remember, plus plus means plus equals 1, which is the same as counter equals counter plus 1. Okay, so this is a shorthand, which just means increase this variable by 1. Okay, it's a very common thing to do. So now we have all the ingredients for a loop in place. Okay, we define a variable that we're going to use to count with as this kind of like accumulator. Then we use the while syntax and we say, while our counter is less than 10, run this block of code. And before we finish the block of code, right at the very end here, I'm increasing my counter by 1 so that the next time we come back, counter will be 1 more than last. And eventually this condition is going to stop being true and is going to become false, right? As soon as counter reaches 10, then it's no longer less than 10. Therefore, this condition will become false. The loop will end and the program will continue. Okay? So let's see what that looks like in practice. So now I can click once, right? And my program can draw 10 circles. If I change this number, right, I could turn this number into 50. Now I click once, my program draws 50 circles, right? Just all in one go. So in other words, the condition that we set for our loop here becomes the number of repetitions that we want to get out of the loop. And of course, this could be less, right? Or it could be a lot more, right? It could be 1,000, whatever. This might take a little bit longer to draw. Now, if I click once, right, I get 1,000 of these circles to appear. So this is really where the power of loops lie. Right? You can set up these structures that will take simple or complex little bits of code, and you are letting the program do the work for you. You're saying, please take this section and then just go to work, just repeat it, do it over and over, right? And we get to control the number of times this will occur. Now, I said earlier, this is the most common scenario for a loop inside a program, where we're going to know ahead of time how many times we want to repeat. So we're going to have these kinds of ingredients: a counter, some kind of condition here, and then a change to the counter every time the loop repeats. Okay? Save this here, just in case something bad happens. There are other circumstances where the while question might be formulated a little bit differently, where it's not necessarily counter based. Perhaps like an example would be an algorithm where you're searching for an answer. So until you find that answer, a while loop would repeat. But those are kind of a little bit more unique cases. This is the most common scenario. Okay? So there's something that I need to point out at this time. So we have to be very careful though when we work with something like the while loop. We have to be careful because there's a possibility, right, that our program might get stuck, might get trapped inside the body of this loop. Okay? How, you might ask? Well, let's say I'm not going to run it because I don't want my browser to get crash, my program to hang the browser. But let's say we take out this counter plus plus, right? Think about what's going to happen. We're going to set counter to 0. Then we're going to tell the program, as long as counter is less than 100, I want you to do this part, right? Just repeat this over and over. Okay? So if there is nothing inside my loop that's modifying the counter over time, then this condition will always be true, right? It will never go to false. So if that situation happens, what we have on our hands is called an infinite loop. And as you may guess, infinite loops are bad. The reason for that is that our program is literally going to get stuck in here, right? We'll never reach the end of this mouse pressed event. Therefore, we'll never go back into draw. And what this will look like to the user is just a frozen, stuck program. It's just going to get stuck in this little infinite loop, and there's no way to get out of it. Sometimes you can interrupt it by pressing stop. Sometimes you have to close the tab and reopen altogether. So infinite loops, just be a little bit careful when you're playing around exploring the while loop. You have to make sure that this condition, right, there's a way for it to eventually become false. As I said, most of the loops that we create kind of follow this general pattern of counting up or counting down. So it's a little bit harder to create an infinite loop, because then you won't, unless you forget to change the counter inside the loop in some way. Okay? In other more esoteric scenarios where you don't necessarily know how many times the loop is going to repeat ahead of time, so there's always this kind of possibility that, is this going to go to infinity? And just something to be aware of and something to look out for. So if your program is mysteriously hanging and crashing, check your loops. Just make sure they have a way of finishing at some point. Okay? So very important here that inside the loop, right, not outside. So notice my curly brackets, right? So we're in the body of the loop. As this code gets repeated, this counter needs to change, right? So here we're doing the simplest thing. We're just increasing the counter by 1. So that eventually this condition will break. All right. So this is the while syntax, right? Very, very similar to the if syntax, right? The difference again is that if will check the condition only one time, and based on the answer, we'll either run the code or skip it. Whereas the while loop will just keep trying. It's going to keep coming back, run the code, come back here, check the condition again, and then rinse and repeat. Okay. All right. Okay. Now, we said in the beginning we have 2 flavors of loops in a p5.js script. We have the while loop, which is kind of the more general one. And then we have something called the for loop, which we're actually going to be using 99% of the time. Okay? Let's take a look at the syntax for the for loop. Okay. So the for loop basically exists as a specialized version of the while loop. It's based on this idea that you're going to have a variable that you're going to use as a counter, And it's essentially a shortcut syntax to set up the kind of loop that we just set up with a while loop. Okay? So it's going to be useful primarily for setting up loops that have a fixed number of repetitions. And as you'll come to learn as you program, this is actually the most common scenario. So the for loop syntax looks something like this. We're going to use the keyword for, and then we're going to have these parentheses here, and inside of it, we're going to have 3 sections separated by semicolons. Okay, we're going to have a counter, a condition, and an increment. And then we're going to, same idea, we're going to use curly brackets to define a body, a section of code that we want to repeat. Okay? So the for loop is probably the weirdest bit of syntax we've run into so far. So let's unpack it in an example here. Okay. So as I mentioned, right, the while loop that we created here represents kind of the most typical scenario where we're going to have something that's counting and we want to repeat based on the counter and a certain number of times. So the for loop exists as a shortcut to set up this kind of structure. Okay. So let me put this into comments here. Okay. And let's set up the equivalent version that's going to use the for loop instead. Okay. So the for loop has the syntax for. Okay. And then we define a block using the curly brackets. And then in the parentheses, this is where it differs a little bit. So in the for loop, we're going to put basically the three ingredients that we put in the while loop. Okay. So the first part is going to be what's called the counter. So this is where we define a variable that we're going to be counting with. Okay. In the while example, we created a variable called counter. We initialized it to 0, right? So we're going to take that portion here and we're going to use it as the beginning part of our for loop. Okay. So this is the part 1, the counter. And then we use the semicolon here to separate the 3 parts that go into the for loop. Very important to use a semicolon here. It's tempting to put a comma. It's not going to work. Semicolon is the syntax that the for loop calls for. Okay? Just so we remember, I'm going to put a note here. We have the counter, the condition, the increment. Okay, so this is the syntax we want to follow. So part 1, we brought in our counter. The middle portion is going to be the loop condition. Okay, this is identical to what we put as the loop condition for our while loop. We're going to say as long as counter is less than 100, repeat. Okay, so we'll put that in as the middle portion of our for loop. And then we put another semicolon. Okay. And then finally, we have the increment. The increment is we say something needs to happen to this counter every time the loop repeats, otherwise we're in trouble. We're going to get an infinite loop. So in our case, our increment was this bit of code over here. We said every time the loop is about to repeat, take the counter, increase it by 1. Okay? So we're going to bring that into the last portion of the for loop. And then in the body of the loop, we'll just simply use the same code we had before. I'm going to copy and paste this. I'm going to remove the comments. Let's fix the formatting a little bit, and then here we go. So now we have the equivalent loop we had before, the while loop, except now we've written it using the for loop syntax. So you can see the for loop basically is like a shorthand, is a more compact version of writing this style of while loop. Okay? And it forces you to put in the 3 basic ingredients that you need for a successful loop that counts. You need a counter, you need a condition, and you need to remember to change your counter over time. So this makes it much easier to not screw up because you have to put in these 3 things, right, in order for the for loop to work. So when we run the code here, we have the same result, right? We press, and this particular example is repeating 100 times, right? So every time I click, it's adding 100 more circles to my canvas. I can clear the background with B and so on and so forth. Okay? Very cool. So now we have the power to take a section of code, right, and set up a for loop or a while loop. But again, we're going to kind of use the for loop most of the time because it's more compact, it's quicker to write, and it's harder to make a mistake because we're going to remember, we're always going to be reminded to put in our 3 basic ingredients for looping. Now we have the power to take a section of code and then just repeat that section over and over as many times as we'd like. All right, very cool. So the while loop has its uses. But unless we really need to use a while loop, we're going to probably stick to the for loop for 99% of what we need to program. And then once in a while, having this more general version might come in handy, but while loops can be more dangerous because you have a chance of a infinite loop happening. Okay? There's still a chance, by the way, to create an infinite loop with something like a for loop, but it's less likely, right? Because you are forced to put in that increment to change of some kind of change to the counter in that last portion over here. It's a good reminder that you have to have those three ingredients. All right. So this is how we take sections of code in programming and just repeat them, loop them, without having to do some kind of insane copy and paste. So if you ever find yourself in a situation where you're doing something and you're like, oh, I want to do more of that, and then you're copying and pasting blocks of code all over your program, just stop what you're doing and think about, could I do this with a loop instead? Okay. And it's 100% going to be better. Amazing. So now that we know about this for loop syntax, we're going to leave it at this for this particular lesson. In the final lesson for this week, we're going to talk about leveraging our counter inside the loop. So right now, everything we're doing is just random, but there are times when we want to set up repetitions, but we also want to look at where we are in the sequence and be able to do things more in a linear kind of way. We're going to talk about this in our next example. I will see you there. Take care.